Next, we're going to be using sum and difference formulas, and what those allow us to do is to be able to find exact values for angles that are not on the unit circle. So on the sheet that I gave you earlier this week, for example, 75 degrees isn't on our unit circle. What our sum and difference formulas allow us to do, and here's what they look like on this sheet. Now, as far as writing those out, notice the plus or minus piece here for sine and the plus or minus piece here for cosine. What we actually have is we have two separate pieces. We can either be adding our angles or subtracting those angles to get to where we are trying to go. So for example, if we have the sine of 75 degrees, if I look at the unit circle, I could either add two angles like 45 and 30 to get to 75, or I could subtract two angles like 135 and 60. And these different formulas allow us to do that. So when we're looking at our sheet, here we have the sine of our two angles. We can either add them, and notice when we're doing the addition that that's on the top. So that means what I'm going to do is I'm going to take sine and cosine. I'm going to be taking my two different angles here, and I'm going to, and again, I go with the top. If I'm adding, then I add. If I go with the bottom piece, then I go with the bottom here. Notice on cosine, same idea. I have a top, and a bottom, and that separates these two into these two different formulas here. Back to our problem, here we're going to find the exact value of sine of 75. So I'm going to use the sum formula, and I'm going to take 45 plus 30 because that adds up to 75. And so what I now have is I have values that I know are on my unit circle at 45 and 30 that I'll use to solve this problem, find the exact value of 75. So now what I have is I have my two separate angles, the 45 and the 30, and that's what I'm going to put in now into the formula. So I am looking at the sine of 45 times the cosine of 30 plus the cosine of 45 times the sine of 30. And we can use our unit circle then at this point and find these values. We know that the sine of 45 is equal to the square root of 2 over 2. Cosine of 45 is also equal to square root of 2 over 2. Then we have our cosine of 30 is equal to the square root of 3 over 2. And our sine of 30 is equal to 1/2. And so we're multiplying these values. I'm going to multiply this side and multiply this side before we add them together. Follow your order of operations. So we end up here with square root of 6 over 4. And here we have square root of 2 over 4. And now we can have an exact answer of square root of 6 plus square root of 2 all over 4. Now, had you used the difference formula and picked two angles, you're still going to end up with that same exact value. Next example, we're looking at finding the exact value of cosine of pi over 12. Now, we have an angle here in radians, and again, this is something that is not on the unit circle. Now, when I have an angle like this, what I want to try and think of is numbers, fractions I can use to get there, and to have a pi over 12, I'm going to just think of this as 1/12. And so I want to find some values where I can maybe subtract two fractions that have a common denominator of 12 and will equal 1/12, like 4/12 and 3/12, for example. Now 4/12 would reduce to 1/3, and then 3/12 would reduce to 1/4. Now those are some values that I do have on my unit circle. I could think of this as 1 pi over 3 minus 1 pi over 4. And so when I'm looking at using the difference formula, now I'm going to look at using cosine here, and I have two angles, and I'm going to subtract them. And so when I'm solving this problem, I'm going to use these two angles. So in using our difference formula, I'm going to take the cosine of each of those angles, take the product there, plus the product of the sine of each of those angles. So in this case, we have our two angles here. I'm taking the cosine of each plus the sine of each. Now we know that cosine at pi over 3 is equal to 1/2, and cosine of pi over 4 is equal to the square root of 2 over 2. The sine of pi over 3 is equal to the square root of 3 over 2, and sine of pi over 4 is equal to square root of 2 over 2. So I'm going to multiply here. We have square root of 2 over 4 plus when we multiply here, we end up with square root of 6 over 4. So our exact value for the cosine of pi over 12 would be equal to square root of 2 plus square root of 6 all over 4. For this last example, we're looking for the exact value of cosine of alpha plus beta, and we're given some information here where we're told our alpha angle is in quadrant 1, and we're given our sine value there, and we're told that our beta angle is in quadrant 2, and we're given our cosine value there. So what we need to do with this is start off by drawing a triangle for each of these. Here we've drawn our triangle with alpha in quadrant 1. We're given that sine is 12/13, so we can use Pythagorean theorem to find the adjacent side is 5. And here we have our triangle with beta in quadrant 2, and we're given that our cosine value is -3/5, so -3 is our adjacent side, 5 is the hypotenuse, and again Pythagorean theorem tells us the opposite side is 4. Now we're looking for the sum of the angles here, and we know that our cosine, as far as the sum, cosine, we find the cosine value of each angle, find the product there, and the sine at each angle, and then we're going to subtract those products. So then what we do next with this is we're going to, for our alpha triangles, we're using this alpha triangle. And for the beta angle here and here, we're using our beta triangle. So we just need to make sure that we're using the appropriate triangle as we go through and fill in these values. So first we're going to find the cosine of alpha. Here's alpha. Cosine then is adjacent over hypotenuse, so that would be 5 over 13. And then here for our sine of alpha, we were already given that that is 12 over 13. And then for our beta values, we're using this triangle. Cosine of beta is -3/5. And then our sine value would be 4/5. And we're going to take the product of each of these sides, and then we're going to subtract those values. So here I would have a -15 over 13 times 5 is 65. Minus, and then here we're going to have 12 times 4 is 48. Again, 13 times 5 is 65. So when I subtract those values, and -15 minus 48 would be equal to -63 over 65. That would be our exact value for our cosine of alpha plus beta.